All right, welcome back. This is an example of simple interest, and what we're going to do is we're going to take a look how simple interest is shown. This looks exactly like she had $1,000. She got 10% interest. That was $100. When we added that $100, she got $1,100. Here's what happens after the second year. She does 2 years and she gets $200, and then adding that she gets $1,200. What I want you to do is look at this formula. The formula is interest over time is principal times rate times time, and you can see all this in the instructions in the diagram above. Draw a line under the principal. Okay, so here we go. Here is a principal. This is a principal all the way through here. These are the word, this number here, 1,000. Oh, let's just find them all. All of these are 1,000. Okay, so we're indicating where our principal is. All right, that's good. Circle the interest rate. So this is the interest rate. This is the interest rate. We got the interest rate here, and we've got an interest rate here. All right, now what are we going to do? It says, and write the decimal equivalent. So 10% is 0.10, 10/100ths, 0.10, 0.10. And this is really, when you do problems like this is how you have to start thinking. How are we going to get that? Because it's really 2 times 0.10 times this. Of is another word for times, by the way. I think you know that. Okay, here we go. Let me put this here. Okay. Draw a box around the total interest. Okay, I'm going to even switch colors here. So the total interest in this case was 100, and down here the total interest was 200. Oop, and I totally missed it. Here it is. A nice big 100 and a nice big 200. Place a star next to the value that represents time. All right, let's go ahead and have another color, and time is represented right here. This is the 2 years, so time is here, this is time, and this is time. And here there's an implied one, but it certainly didn't get put into the picture because we saw there was 1 year, but we don't write one when we already know it's 1. All right, that's very good. We're going to pause a sec here. Okay, now we're going to create a formula for the total value or cost of a savings account or loan. So the thing is, the total value, TV, total value, is the beginning value, the principal, what you started with, plus everything you earned in the way of interest. And some people even think of total value. They see this common P and they say, oh, we take this P out and we can go 1 to hold that P. This is, the reverse distributive that you guys know. And then 1 over RT. Okay, and either one of these will do it. The total value is the cost of the loan, the $1,000, plus the interest earned, the $200. And the final instruction on this one is highlight the total value of the two in the 2 examples above. So value that is the total value. This guy here is total value, and this guy here is total value. Simple interest. But there's something else called compound interest, and you're going to see that this is in the best interest, so to speak, of the person who is making the money off the principal. So lenders make money off the principal and investors make money off the principal. In the 1600s, banks realized that there was another way to compute interest and make even more money. With compound interest, banks calculate the interest for the first period, add it to the total. So this looks like what we saw before, 1,000 getting 10%, and now we have 1,100. And then calculate the interest on the total for the next period. So notice the difference. Here we see 1,000, and here we're getting interest on 1,100. Last time when we did this problem, we had $1,200. So by compounding the interest, we've actually upped the value of money by $10. You can see there's a much better amount of return. And now the next batch of money is going to come off of going $1,210 times 10%. And that's going to give us, well, basis that now instead of $110 interest, or yeah, she's going to get $121. So the next value will be 1210 plus the 121 that she makes, and we've got 3. So you can see here that now we actually have an extra $31 from what we had before. So what we want to do is we want to develop a formula for what's going on here. So in the first year we start with $1,000 and we add 0.1, we add 1%. Let's make this simple. 0.1% is 1/10 of 1%, which is 0.10, yes. So we have times 1,000. Let me get this in here, which is the same as saying 1,000, because we have it in common with both of those, and now we're moving into looking at a little something that we saw before, times 1 plus 1.1 times 0.1. Leave that into my parentheses. And that gives us 1,000 times 1.1, which is $1,100. That was our first year. Now we go back in here for year 2 and we say $1,100 plus 0.1 times $1,100. And that's going to be, we're going to take out, now we get to take out $1,100 back to the invisible 1 here and the 0.1 here. 1 plus 0.1 again, which is 1,100 times 1.1, which, if we think about it, this 1,100 was one. Let's get something to really show. So this is 1,000. I'm replacing this guy into this. Okay, so what I'm doing is I'm saying 1,000 times 1.1, sorry about this, I'm going to get rid of that in a minute, times 1.1. And we're going to our $1,210. All right, so now we go back in 1,210. And here again, what we see is we have 1,210, 1,210. And this guy here is what generated 1,210. So I'm going to take it, plug it in here. At this point, I'm hoping that you're going to be able to see that I'm going to put this 1,000 times 1.1, 1, 2, 3 times in for this 1,331, plus I have one more. So really, it's perfectly legitimate for me to say 1,000 times, because I'm getting tired of writing this, and I imagine you are too, to the 4th power. And if we think about that, and let me just tell you what that value is. That value gives us $1,464.10. So we're going to repeat the whole thing over again. But if we look, what we have is a nice pattern going on here. We have 1,000 times 1.1. So we notice 1.1 to the year 1, 1.1 times 1 plus 1.1, that's the year 2. So our 1.1s are principal, because this 1 represents the principal while this is the interest. Our principal plus the interest times power is going to give us our answer. So the year 5, believe it or not, is going to be as simple as saying 1,000 times 1.1 is going to give us our answer, which is a value of $1,610.51. Now we saw in the earlier problem that a year 5 with simple interest, it was $1,500. So this is compound, and this is simple. You choose. All right, let's talk about this one more time. First of all, this is just a definition. So this is the formula that's going to work all the time for compound interest. This is certainly the formula you're going to hope to have. Future value, present value. Future values are ending values, so this would be the future value. Interest rate and number of years. Using the second column, so we're going to look here at this column. What do you notice about the present value? So if you notice here, what I notice is that the value ascends. It gets bigger and bigger as we go, which means we're getting more interest because we're getting money on more money. What do you notice about the interest rate? Stays the same. So in the sequence, so I hope what you notice is that the future value gets greater every time, and it gets greater faster than it did with the simple compound, with the simple rate. Is this sequence arithmetic or geometric? Well, because it doesn't go up by a uniform amount, it is geometric. And it's also geometric because it came from a multiplication operation.